Imagine a circle, no start, no end. It keeps going, always returning to where it began. That's a loop, a path or process that repeats, creating rhythm and predictability. Loops are everywhere, from music to tying your shoes. Every repeated step is a loop. Loops bring order to our world, helping us find structure in what might seem random. The universe thrives on loops, from atoms vibrating to galaxies spinning. Loops can be tiny, like a heartbeat, or vast, like a planet's orbit. They're cycles, endings that are also new beginnings. Loops are the blueprint for life and the structure of time itself. Once you start to notice loops, you realize they're everywhere, woven into the fabric of our lives. They're in your heartbeat, the steady rise and fall of your breath, and the endless dance of the changing seasons. Every moment, something is cycling, repeating, returning. Nature is full of cycles. Spring blossoms into summer, which fades into autumn, then winter, and then, almost magically, the cycle begins anew. This rhythm is the pulse of the natural world. The water cycle, evaporation, condensation, precipitation, keeps life thriving. Water rises, falls, and returns, nourishing every living thing, connecting clouds to rivers and rivers to oceans. Even math is built on loops. Clocks that circle endlessly, numbers that repeat in patterns, and the infinite digits of pi, spiraling on without end. Loops define the orbits of electrons around atomic nuclei and the majestic paths of planets circling their stars. These cycles are the foundation of both the microscopic and the cosmic. Earth loops around the sun year after year, while our entire solar system spins in a vast, graceful loop around the center of the galaxy. These patterns aren't random. They're the universe's way of creating order from chaos, shaping everything from the spiral of a galaxy to the veins in a leaf. From the tiniest atom to the grandest galaxy, loops are the silent architects of reality, building structure and harmony at every scale. They're the reason life is possible, the rhythm behind every beat, every breath, and every orbit, an invisible thread connecting all things. Loops connect us to the cosmos, reminding us that repetition is a universal language, spoken by stars, planets, and living beings alike. The same principle, a return to the beginning, shapes everything we know, from the cycles of nature to the mysteries of the universe. Loops are the heartbeat of existence, the quiet force that keeps the universe in motion, forever returning, forever beginning again. So, how do we study loops? Enter loop theory, the science of repeating systems. Loop theory uncovers the rules behind cycles, helping us predict and harness their power. It's like writing the sheet music for a song's chorus, breaking down patterns to understand how they work. In computer science, loops are essential. They tell machines to repeat tasks, powering everything from video games to social media. Loop theory's logic turns simple instructions into complex processes, but it goes further, studying feedback loops where cycles interact. Positive feedback amplifies effects. Negative feedback stabilizes systems. Understanding these interactions is key to fields from climate science to biology. Loop theory reveals the hidden order in our dynamic world. Studying loops isn't just curiosity, it's a quest to understand the universe's mechanics, the hidden patterns that shape everything around us. From the tiniest particles to the largest galaxies, loops are everywhere, quietly governing the rules of existence. In physics, loop quantum gravity suggests space-time itself is woven from tiny loops, possibly uniting relativity and quantum mechanics. This theory could reveal how the universe is stitched together at its most fundamental level, offering a glimpse into the fabric of reality itself. In medicine, many diseases are loops gone wrong, like cancer's endless cell division or autoimmune feedback gone awry. These biological loops, when disrupted, can lead to chaos within our bodies, making understanding them crucial for breakthroughs in treatment. By breaking these cycles, we can restore health and bring balance back to our systems, offering hope for recovery and new therapies. Climate science relies on understanding feedback loops, like Arctic ice melt accelerating warming. These loops can amplify changes, making small shifts in the environment lead to dramatic consequences for the planet. These models help us predict and address global challenges, guiding our actions to prevent disaster and create a more sustainable future for all. Economists, engineers, and neuroscientists all use loop theory to predict, control, and innovate. By mapping these cycles, they can anticipate problems and design smarter solutions. Mastering loops empowers us to build better technology, heal disease, and protect our planet. It's a tool for progress, resilience, and hope. The study of loops is the study of how things work, how systems interact, and how change ripples through the world. It's the key to unlocking reality's deepest secrets, revealing the profound connections that bind everything together. Loops are everywhere, from your breath to the orbit of Earth. shaping reality at every scale. Understanding loops connects us to the universe and to each other. Loop theory powers our technology, music, and medicine. As we face challenges like climate change, grasping feedback loops is vital for survival. In AI and neuroscience, loops may hold the secret to consciousness itself. Every repeating pattern, from a bird's song to the tides, is a reminder of the loop's power. By exploring loops, we learn the language of the cosmos and ourselves, the loop simple, profound, and the universe's favorite trick.